G'day viewers, and welcome back to our channel. Today's episode I would like to follow up on our recent video on welding symbols. There were a couple of little things that came up during that video that I'd like to tidy up and clarify. One was the magenta line work of the welding symbol with the black background really didn't help or visualize what the functionality was with the macro, so I thought we'd look at that in a little bit more depth to highlight that. And also we had an issue with some of the welds disappearing, which I have done some research on and found why that has been occurring. So well, I believe I understand why it has occurred, so I can explain that. So that might be helpful for others if they are customizing their welding symbols. Okay, let's take a look now at a few different things. So I have again we've got 3 monitors happening, so I've got my main monitor which we'll come back to, but I'd like to start with the Autodesk help desk website. So there are a couple of support pages here. This particular one is for the weld template configuration, so this will help to understand how they've put together the macro symbol. Essentially what you have is an AutoCAD block of information which is then being utilized by the Advanced Steel software to take parts of this information to produce a welding symbol in the software application. The other one that I've highlighted here, and I'll put these links in the information in the video, so you could go have a read of this for yourself. So this one is about creating a new weld symbol. So in our case, we have produced, or we have added some welding symbols which are not part of the Australian standard. They are part of the ISO 2553 standard, but we felt that we wanted to include them in our macro to add some additional functionality. So, and those were weld symbols like the partial penetration type welds, which we call the broad-faced V welds and the broad-faced bevel welds. So we've added those and a couple of others that are actually in the Australian standard which weren't in the out-of-the-box solution. So we've added those into our macro. So it's probably a total of about 5 or 6 different weld symbol types that we've added to our macro to improve its functionality. So the important part on this particular one is that I can show you to save you opening up my database table, and hopefully you can see it here. It's line 22. So line 22 is for dummy welds. So they're welds where you want to put a weld in and not have a weld show up. So an application for that is if you have a weld for holding an assembly together, but you don't want to actually call up a weld, you just wanted to make the 2 beams join together for the purposes of being able to create an assembly drawing. You could use a dummy weld. We've actually created our own weld type called an assembly weld, which does that same functionality. However, what I've found with my readjustment, because I rewrote this table to suit my my layout or my welding symbols, and I basically thought, oh, I don't need a dummy weld, I will remove that. So in my previous video, line 22 happened to be the backing material for removed, and when that weld symbol was chosen, the macro must be looking at line 22 of this table and saying, well, that one there, don't show that weld. So all I've done there is move those 2 welds, because I had line 21 for the top weld and line 22 for the bottom weld. I've moved both those two lines from that table further down, and hey presto, problem went away. So it's obviously some hardwired coding that is in the macro that I can't see because we haven't got access to the macro coding itself, so we have to dig around in the dark to try to find out how it's actually working. But it would be my suggestion that line 22 remain as a dummy weld with two empty cells in these two columns. So if you're customizing your own, don't use line 22. That would be my advice. Okay, so that is the couple of pages from the Autodesk support site. I'll now go have a look now at the top left hand corner here. So we've got the two sort of main standards that we've been using to build up our macro. Sorry, just having some of my first coffee. So on the left hand side here, you can see the screen moving here. This is the diagrammatical representation for the Australian standard for showing welding symbols. So this is AS 1101.3, and you can see how they have called up, or how they want things represented here. And on the right hand side we have the ISO 2553 version of how they would like to see weld symbols represented. Now there are some things that are in the ISO standard which I think could be in the Australian standard, which we intend to include in our macro to improve some of the functionality or the usefulness of the welding symbols for our business. But there are things that at the moment we just can't get the advanced steel macro to get to where we'd like it to be more compliant with some of these standards. So at the moment we can get close to get some of the functionality, but not all the way. And yet to get all the way, we either have to wait for Autodesk to revise and rebuild their macro, or create a separate macro which is manually inserted that has full functionality. So we will come back to that. Okay, so I've just gone back to my main screen now, and you can see on screen I have 4 beams. So there's a couple of beams that have been welded together to create an assembly, and on this bottom beam here I have added 24 welds, which are the list of 24 welds that we have in our macro. So I will come down here. So this is a backing weld, and we've got a backing weld on both sides here, so it's a double weld. And I've put the style of weld that it is in the additional information, so it will show up on the assembly drawing, so I can double check to make sure that all the weld symbols are matching up to the correct symbols and shapes. So this is how I've done it to do a check. So I've then gone and created an assembly of this beam. So here I've just got an elevation on a drawing for an assembly. So you can see here, this is a stick assembly, it's a rafter, it's given us my part number. So, and I've moved it off to the side so that hopefully some of these colors will be clearer with this sort of grey background, as opposed to the black background that we did the other day. So there are 24 welds here, so we'll run through those in a second. And I've added here a weld that's been added in manually into this assembly drawing. All the rest of these welds are coming from that beam that I just showed you. So if I look at this particular weld here, you'll see that it's grayed out. That's because that information would need to be changed back in the model and not in this drawing, whereas the information for this manually edited one can be edited in this drawing. So we'll come back to that manual edited symbol, and we'll just run through these welds. We'll start up the top here. So the backing bar removed. So this is the one that was on line 22 in my previous video that was having trouble showing up. So it's now showing up, which is good news. So that's a backing bar. So this is where you would put a backing bar, and on the other side you would put a V butt weld. So you'd have a V butt weld with a backing bar that's to be removed after the weld. So that's how it would be used. You'll notice that there's no number in front of here. So we've got a 6mm V butt weld here. We've got 6mm highlighted here or indicated here, but no numbers here. So in our macro we've used 1 as our default, and if a size of 1 is being used, so I imagine if I come in here, if I open this up, even though I won't be able to edit it, you'll see that the weld thickness is 1, and on the double the weld thickness is 1. If you use 1 in our system, a number won't show up, because for this backing bar you don't need to show a value in here. So what we have decided to do in our business is traditionally people would put a note on their drawings to say that a 6mm fillet weld, or if it's a fillet weld, if it's not noted, it'll be a 6mm weld. Now, the reason behind some of that theory is it's come from how we used to do things back when we were on a drawing board. So to save time, to not have to put in the 6 in front of a fillet weld every time, we would do a global note to say, hey, if it's a fillet weld and it's not noted, it will be 6mm. So that theory has come from, back in 1960, years ago. We're now on computers, and it doesn't cost us any time to actually put a 6 in front of the symbol. So we've made the decision now to say that we will put that number in, and it will show whether it's a 6 or a 4 or a 10 or an 8. We are going to show that value every time. So it's not going to be this unless noted otherwise. If it's a 6mm fillet weld, we're going to show a 6 and the fillet weld every time. It doesn't cost us any money. In fact, I think it actually helps and shows more information. So in this case, we believe that is a better option. So we'll just pan along here. So we've got our backing bars, and backing bars permanent. I'll just run through the top. That might be the easiest, then come back along the bottom. So we've got a traditional V butt weld, a U butt weld, a surface weld, a stud weld, a square edge weld, a square butt weld, a spot weld in the middle, spot welds, a seam weld in the middle, seam welds, scarf welds, which I've never actually caught up. I was considering getting rid of scarf welds from our library, but I've kept it in there for now. A backing weld, a bevel butt weld. So these are some of our newer ones with our partial penetration butt weld or a broad-faced bevel butt weld. You can see the symbol we've added there, which has come from the ISO standard. Another partial penetration butt weld, a broad-faced V butt weld, and the symbol that we have gone with there. The fillet weld, the flange corner weld, the flange edge weld, the flare bevel butt weld, the flare V butt weld, the J butt weld, a plug weld, and we're back to our backing bar permanent down here. So they're the 24 different varieties of weld symbols that we have in our current welding symbol. So we'll have a look now at this manually edited or manually added weld symbol to this particular assembly. So we'll open up the dialog box here and start to play around with some of these values so you can see how these will work. So we'll put a V butt weld in here, which is going on below the line. We'll change that to 6. We'll change our weld to 25 at a pitch of 400, and you can see where these values are changing here. Now this is a V butt weld, so it is a it'll have like a full weld, so it's more likely to be something like a 60 degree. It's going to be a sight weld. I'm going to say it's going to be flat, and it's going to be ground back, and I'm going to say that it has a root opening of 2 mil. The effective throat and preparation and the prefixes, these values we are not using, or we haven't been able to include them as functionality at the moment, because we feel that it causes more harm than good, so we've decided to leave those out at this time. So let's try to do something with the backing bar removed. So we'll put in the backing bar removed, and because we've got this thickness here, so I'll just put a 6 in here, but that is irrelevant for this bar. So if we use a 1, that is more in line with how that would actually be used. We get rid of the surface shape, the preparation will go back to standard, and we're going to say that, you know, this is, we'll call it actually, we'll put a stagger symbol in here. So you can sort of see now how this functionality is working. I'll just change that back to a shop weld. The interesting part that we have found is even with our drawing presentations, we have not been able to get the sight weld to show up on an assembly drawing, although you can add a sight weld manually to an assembly drawing, even with the presentation and asking it to show up the sight welds on an assembly drawing. It for some reason must be part of the coding that it just won't allow you to do it, and only sight welds will show up in drawings that have been created by cameras for erection type drawings. So we haven't found a workaround for that as yet. So the other thing that we have found is with our fishtails and our descriptions at the end, we haven't found any way to control the size and shape and angle of these fishtails. So you can see how these fishtails seem to be matching the height of the text. That seems to be the determining factor. So if you add a line in here, you can see how that changes the size of the text by putting lines in here. So you can put in dots or something like that to make it sort of behave differently. So again, no, it doesn't follow a standard, but that's what we've got at the moment. Let's just put in back to our Phillip Weld. So let's put in a Phillip Weld here. If I can find my Phillip Weld, where are you? There you are. We'll make him a 4mm Phillip Weld. We will put a convex, and instead of saying that it's a stitch weld, we'll put in here that it's going to be machined. Well, let's say it's going to be machined flat. There we go. And just for giggles, we will make that a 2mm root gap. So you can see how the way that we've put this macro together is, I would say, vastly improved from the out-of-the-box solution that comes with Advanced Steel as its foundation software. So that if you're looking to improve your welding symbols for your documentation, hopefully this will provide you some insights of what can be achieved, and that all is not lost in that the out of the box one can't be changed. It can be changed. I can attest to the fact that it's not easy, and it takes a lot of work to actually get these symbols to actually have this functionality, but it can be done. Certainly we would suggest that Autodesk should provide this functionality out of the box, so that companies who are getting Advanced Steel and starting to implement it into their company systems, that they don't have to spend all this time getting a functional welding symbol to work. So that is that is how we've got it to work. So hopefully that will shine some light or provide some insights to others who want to customize their welding symbols, and save you some grief. Certainly we have found plenty ourselves to when trying to solve this particular issue. All right, well, thanks for watching this video. I hope it's been helpful. Just hit the subscribe button or the like button if you want to see more content like this. And again, always remember, if your job's worth doing, it's worth doing right.